My name is Abraham Otieno. I'm a mathematics teacher or lecturer. I will teach something on Fourier series, just a question. This is Diploma in Electrical Engineering, Module 3, Electrical Engineering. So we are going to see one question in Fourier series. So that is June-July 2018, question number 8A. So the question is here. We have 13 marks. It's a 13 marks question. So the question reads, determine the Fourier series representation of the function. So for you to start tackling this question, you need to start drawing the sketch. You need to draw the sketch diagram for this one. But if you don't have time, because it takes a lot of time, it's only 13 minutes, there is no need of drawing or sketching the graph. So let's sketch it. So this one is in the function of f of t to the function of t, and is the range of negative pi to pi. So it is in the range of pi to negative pi. It is the range of pi to negative pi to pi. So what do you have? From negative pi to 0. From negative pi to 0, we'll have 0. Our f of t is 0. So it is at this point. In the range of 0 to pi, we have t squared. And whenever we see a t squared or any valued power, that means that is a curve. For example, x squared is a curve. X power 3 is a curve. So this one is our curve. Here is our curve. So this one is our sketch diagram. So after this, we need to know or to write the Fourier series formula. And in our previous videos, we have done that. So we have f of t, the function of t, is given by a half a naught plus the summation of n is equal to 1 to infinity, open the bracket, an cos of nt plus bn sine of n of t, close the bracket to the respect to d, to the respect to x. Sorry. Now, we need to find the constant of a naught, an, and bn. We need to get the constant of a naught, bn, an, and bn. Now, let's start with a naught. And our a naught is given by 1 over pi, the integral of negative pi to pi, the function of t dt to the respect to t. Now, what is our answer? I have 1 over pi, open the bracket, the integral from negative pi to 0, the function is 0 to the respect to dt, plus the integral from 0 to pi. Our function is t squared dt to the respect to t. We can close the bracket. Now, without doing anything, if I integrate this, it will approach to 0 confidently. So I will have 1 over pi, open the big bracket, the integral of 0 to pi, t squared dt, close the bracket. Now let's integrate this one. So for you to tackle this topic, this one is a year 3 topic in electrical engineering. It has a relation in year 1 topic, that is calculus 1 and 2, the integration and differentiation. Those are the things that we are going to use here. So let's tackle this. I have 1 over pi open the bracket, t power 3 divided by 3. In the range of 0 to pi. So any place we have t, I replace it with pi. So I have 1 over pi, open the bracket, pi power 3 divided by 3, minus 0 power 3 divided by 3. Of course, this one is just 0, there is no wastage of time. So I have 1 over pi, open the bracket, pi cubed divided by 3. So this and this will go. So I have here 1 here squared. I will remain with pi squared divided by 3. Therefore, my A node is given by pi squared divided by 3. Pi squared divided by 3 as our first constant. So we want to discuss the second constant, that is AN. And AN is given by 1 over pi, the integral of negative pi to pi, the function of t, cos nt dt to the respect to t. Therefore, I have 1 over pi, the integral of negative pi, the integral, not the negative pi rather, but we have the range of negative pi to 0. So we have negative pi to 0, and the function is still 0. And the function is still 0 dt, plus the integral of the range of 0 to pi. 0 to pi. And the function that we have, it is t squared. So we have t squared, I forget, sorry, there's something here. Sorry, we have 0 cos nt dt plus the integral of 0 to pi. Our function is t squared multiplied by cos of n of t dt. So, if I want to integrate this one, all of these will approach to 0 confidently. All of that will approach to 0 confidently. So I will have 1 over pi, open the bigger bracket, the integral of 0 to pi, t squared cos of nt dt. Now, if I want to solve this problem, I need to use integration by parts. Integration by parts. And we discussed this one in our year 1. We discussed that one in Let me clear this side. The range of my camera cannot see that position. So I have pi, open the bracket, the integral of 0 to pi, t squared, cos of nt dt. Now, if you want to solve this problem, you need to use the integration by parts. Use integration by parts. Now, I know you know how to integrate this one by parts. You are going to use the formula of the integral of u dv is equal to u v minus the integral. Now, we learned that how to calculate the integration using integration by parts. We learned that the integral of u dv is equal to uv minus the integral of v du. But I know all of you know how to calculate this. I don't want to go to that direction. I want to teach you another method called the shortcut method. Shortcut method. Why? Because I can see we have a lot of work and we only have 13 marks. So let's use the shortcut method. It's very simple. Just write here sign. The derivatives and the integrals. So make this table. Derivatives and the integrals. So the signs will be just positive, and negative. Derivatives will replace the value of u. Because in our formula, this one will be our u, and this other side will be our dv. So our u is our derivatives. So u is t squared. So let's differentiate t squared once. What are we going to get? We are going to have 2t. So if I differentiate 2t, I am going to get 2. If I differentiate 2, I am going to get 0. Very simple. What about the integrals in the value of dv? And that is cos of nt. So if I differentiate cos of nt, I will get 1 over n sine of nt. If I differentiate this again, I will have negative of 1 over n squared cos of nt. If I differentiate this again, I'll have negative 1 over n over 3 sine of nt. Good, you can copy that. Copy that, copy that. After that now, I don't know whether this space, I'll clear the equation because I know you have the equation. I'll clear this part so that we can use it. So that we can use it. So that we can use it now. So this sign will go with this one and will go with this one. And I have just told this one is a shortcut method. This one will go with this one, this and this one. This one we don't have. Now I'll have 1 over pi, 1 over pi, open the bigger bracket, plus a positive of t squared multiplied by 1 over n sine n and t. So I'm going to have t squared sine nt divided by n. The range of our range is from 0 to pi. 0 to pi. Then we continue. We have negative 2t. Negative and negative will now have a positive 2t. 2t cos of n. Cos of nt divided by our n squared. Divided by our n squared. In the range of 0 to pi. And the last one we have positive 2 multiplied by negative. So I am going to have negative 2 sine nt divided by n power 3 in the range of 0 to pi. Negative is there, 2 multiplied by sine nt is there, power 3. Very good. So, if you use your long method, this is the same answer you are going to obtain. This is the same answer you are going to obtain. Okay. Now, in the introduction part of this Fourier series, we say that sine nt of any value, whether even or odd, so this one will approach to 0. This one will also approach to 0. Therefore, a of what? A of n, constant n, is equal to 1 over pi. Open the bigger bracket. So this one is gone. We have remained with 2t cos of nt divided by n squared in the range of 0 to pi. In the range of 0 to pi. Now, let's obtain the value of t. So we will not waste our time with this 0. So we'll deal with our pi. So I'll have a of n is equal to 1 over pi, open the bracket, 2 pi cos of n pi divided by n squared. So mathematically this pi and this pi will go. So I'll have a of n is equal to 2 cos of n pi divided by n squared. an is equal to 2 pi n. an is equal to 2 cos n pi divided by n squared. Very good. So we have a of n is this one. Now, for a of n, So we know that cos n pi, if this one is odd, it will become -1. We did that. So for example, we have cos of -1 pi, not -1 but 1, it will be -1. Of 3, cos of 3 pi, it will be -1. So we will not waste time for that. So I will have 2 multiplied by that -1 for cos n pi. I'll get -1. So -1 multiplied by 2. I'll have -2 divided by n squared. For n is odd. So if this n is odd, this is what we'll have. What about if n is even? What about if n is even? So a of n is equal to 2 cos of n of pi. N of pi divided by n squared. Now, if it is cos n pi is even, we are going to have +1 or 1. Not +1 but 1. So 2 multiplied by 1 is just 1. So we are going to have 2a of n is equal to 2 over n squared for even. For n is even. For n is even. Now I have obtained the value of a of n is here. When it is even, when it is odd, we also obtain the value of AO. Now let's continue with Dn. Now the last constant. The last constant is B of n. Now B of n is given by the 1 over pi, the integral of -pi to pi, f of t, sine of nt dt. Therefore, B of n is equal to 1 over pi, the integral, we have it. I think it was the integral of -pi to 0 sine n nt dt plus the integral of 0 to pi t squared sine n of t dt. Again, I don't want to waste a lot of time. So this one, it is in bracket. So this one will approach to 0. So I have B of n is equal to the integral of 0 to pi t squared sine of nt dt. You can use the long method. You can use the shortest method to solve this one. So let's use the integration by parts. Integration by parts. So I have sine, the same method. I have the derivative. I have the integral. I have the integral. So sine is just positive and negative. So the derivative takes the value of u squared. So this one is t squared. If I differentiate it is what? It is 2t. If I differentiate this one twice, 2 and 0. What about this one? I have sine of n of t. If I differentiate it, I will have a half. Not a half, but negative n cos of nt, sorry. If I differentiate this one again, I will have 1 over n squared sine of nt. And the last one, if I differentiate this sine, if I differentiate it, it will be this negative, that will remove this negative, and you will have 1 over n power 3 cos of n of t. Cos of n of t. Cos of n of t. Let me clear this side, kindly. Let me clear this side. Now I have B of n is given by 1 over pi, open the bracket. We have positive. So this one will go with this one, this one will go with this one, this one 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 with this one. So positive, this one, so I will have here a negative t squared cos nt divided by n in the range of 0 to pi. In the range of 0 to pi. Plus the second one, negative, it will be a positive. So I have 2t sine of n of t, sine of n of t divided by n squared in the range of 0 to pi. Now the last one, it is also a positive. It will result in a positive. So it is a plus. This is positive 2. So it is 2 cos of nt divided by n power 3 in the range of 0 to pi. So where do we have cos? Where do we have sine? So this one, it will approach to 0 confidently. It will approach to 0 confidently. Now we have b of n is equal to 1 over pi. Open the bracket. I have negative t squared cos of nt divided by n in the range of 0 to pi plus 2 cos of n of t divided by n power 3 in the range of 0 to pi. In the range of 0 to pi. Now, let's see at this equation when the value of n is odd. When the value of n is odd. When the value of n is odd. But before we check, let us put this range. So we have b of n is equal to 1 over pi. Open the bracket. Whenever we have t, I have negative t, not t but negative pi squared cos of n pi divided by n plus 2 cos of pi divided by n power 3. They are the biggest bracket. N power 3. So we can remove the brackets. We can remove the constant outside. So for instance, this one and this one will go, and I have negative pi. This one and this one is negative pi. So I think this one was good. Negative pi cos of n pi divided by n plus, we have a constant here. This is pi over n power 3. So this n will go with the other n. This one. Open the bracket. 2 cos pi divided by n divided by nothing. Now I want to bring this one back again so that we can multiply everything by 1 over pi. Yes?
N cos 2 cos n pi.
Cos? Oh, this one. Yes. Good. 2 pi. So what am I going to have? So for odd number, we know that cos n pi is equal to negative 1. That is our equation. That 1 over pi is equal to this one. Now for an odd, we know that cos of n of pi is equal to negative 1. So therefore, let's do this one together. Negative pi. So of course I have 1 over pi. Open the bracket. Negative pi squared cos n pi. So this one will be negative 1. Negative 1 multiplied by this one, I remain with pi squared divided by n for here. Plus, what about this side? This one is negative 1. Negative 1 minus negative 1, it is negative what? Negative 2. So negative 2 multiplied by this one, it will be negative 4 over n power 3.
So this one is for n. So this one is equal to, if I open the bracket of what we have, I will have what? What do I have now? I have what is common? Let's take the LCM of this one first. The LCM of this one is n power 3. So n power 3 goes here, n squared, and this one is n squared pi squared minus, this one goes here 4 times. So I'm going to have, it's getting more dark, so you can switch on our lights. So we are going to have n squared pi squared minus 4 divided by n power 3, multiply this one by 1 over pi, this pi. So my answer will be Bn is equal to what? Bn is equal to pi squared n squared minus 4 divided by n power 3 pi. So what about if it Bn is given? Bn for n is even. For n is even. So remember, when n is even, we have 1. So here is 1 multiplied by this one. We'll still have 1 over pi, open the bracket, negative pi squared divided by n. Multiplied by 1 will remain the same. Plus 1. Here is 1 minus 1. 1 minus 1 is what? 0. So we will remain here. So for even, we have 1 over pi, not really 1 over pi, but this pi with the other pi will go, so I'll have pi divided by n. So Bn is equal to pi divided by n. Now we have here, this is negative. So for n is equal to, for n is even, this will be our answer. For n is odd, this will be our answer. Very good. Now let's write again our formula. I don't know where to have. Let me clear this place. So, the function of f of t, our formula was the function of f of t is equal to a half a naught plus the summation of n is equal to 1 to infinity, open the bracket, dn cos of n of t plus dn sine of n of t in the respect to dt. Therefore, f of t is equal to a half a naught. What was the answer of a naught? A naught to the power ngapi? Pi over 3. Pi over 3. But this was squared. So I will have 1 over pi, 1 over 2 times pi squared over 3, this one, plus the summation of n is equal to 1 to infinity. Open the bracket. The value of an, I think we have the value of an was negative 2 over n squared cos of nt plus the value of bn was negative pi over n, open the bracket, not open the bracket, but sine of n of t dt. So, you can leave your answer here, or you can continue. If you don't have time, if you leave your answer here, you will still have your full marks. But you need to continue. Now, f of t is equal to, if I multiply this one, I will have pi squared divided by 6 plus, I have negative 2. So I will have 2, I'll leave the negative here, 2, open the big bracket. Let's deal with the cos. And this cos it has the even and odd. Even and odd. So I will have negative 1 over 1 squared. Because this n is 1 and it is squared. So 1 squared cos of 1t plus 1 over 2 squared. 1 over 2 squared cos of 2t plus 1 over 3 squared cos of 3t. We have some. This one is a negative. This one must be a positive. This one will be a negative. Positive 1 over 4 squared cos of 3t plus until infinity. Until infinity. Until infinity. Plus, if we continue with the part of the sign, so the sign we have negative pi. We have negative pi. Pi squared minus 4 for even. Divided by pi. Sine of t. Minus pi of 2 sine of 2t plus 4 pi squared minus 4 divided by 2 pi sine 3t plus negative pi over 4 sine 4t. So this one will be our answer. So you can decide to open the bracket this side for your work to be easy. So this one will be just 1. This one will be 1 over 4. This one will be 1 over 9. And this one will be 14 squared, that is 16. So this one will be 16. Continue subscribing for the channel. Send to many students so that I can begin. Thank you very much.